Let's have a look at some rearrangements of equations with some chemistry examples to help you with the math side of chemistry. The first example I've put is where we're working out the amount of moles of a substance if we know either the mass or the MR. So in this case we've got amount in moles equals mass over MR, and we've been asked to find the mass. So we need to rearrange this equation to make mass the subject of the equation. So we need to get the term mass on its own on one side of the equation. In this case, the way of doing this is by moving MR from divide on one side to multiply on the other. So basically, when you move a term across the equal sign, it changes around. So if it was divide before, it becomes multiply, and multiply it becomes divide. So if we have a look at amount in moles equals mass over MR, and we want to find the mass, we want the mass on its own on the top on the right hand side in this case. So we need to move the MR out of the way. So to move the MR out of the way, we take it across the equal sign. As it was divide before, it's now going to be multiplied. So we then have amount in moles multiplied by MR equals the mass. And if you prefer to have the mass on the left hand side, obviously you can put the equation the other way around just by flipping it over. So you have mass in grams equals amount in moles times MR. If we have a look at another example, example 2, it's the same actual equation, but we're going to try and find the MR. So again, you notice that the MR is not on its own to begin with, it's underneath the equation. You'll need to get it up at the top and on its own. So again, get the MR across to the top. So in doing that, we'll move the MR from divide on the right hand side to multiply on the left, because we're taking it over the equal sign. So then we've got amount in moles times MR equals the mass in grams. So therefore, to get the MR on its own, we need to move the amount in moles. So as we move the amount in moles across the equals sign, it goes from multiply on the left to divide on the right. So we end up with the MR as a subject to the equation equals mass in grams over amount in moles. We can then have a look at some more complicated examples that you'll come across in the ideal gas equation, which you come across in the first year, and the ideal gas equation is PV equals nRT. In this case, P is pressure, V is volume, N is the amount in moles, R is the gas constant, and T is the temperature. So you're often asked to substitute values into this equation and rearrange to find one of the other values. So in this case, we're going to try and find N, the amount in moles. The first thing to do is to get N alone on the top by moving away the terms R and T. So remember, when written like this, if you've got nRT, we actually mean N times R times T. So to get N on its own, we're going to need to move R and T across the equal sign. So it's going to move from multiply to divide. So if we first of all move T, we have PV divide by T equals NR. And then we can move the R term, so we have PV divide by NR equals N. So in the end, we've actually got P times V divided by R times T equals N. We could try doing a different type of rearrangement of the same equation, perhaps to find V, the volume. So in this case, we need V on its own. So this time, if we want V on its own, we need to move P across the equal sign, so it's multiplied on one side, therefore it needs to be divided on the other. So we end up with V equals nRT over P. When you get onto A2, we have to deal with square roots in the equation, and an equation that we use quite frequently when we're looking at acid and bases is the concentration of hydrogen ion, which is the square bracket H plus term, equals the square root of Ka, which is the acid dissociation constant term, multiplied by the concentration of HA, which is a weak acid. So although the equation looks quite complicated, we're actually only dealing with three terms. We're dealing with the concentration of hydrogen ion, Ka, which is the acid dissociation constant, and HA, the weak acid concentration. You see at the end I've actually simplified it down to just three letters as well, if that would help you later on. This sort of equation you would have to work out, say, the value of the term Ka. In this case, you'd have to have a look at trying to get Ka on its own. So you'll need to get rid of the square root on the side on the right hand side. So to do this, if you square both sides, that becomes the hydrogen ion concentration squared on the left, and then the square of the square root, which becomes the normal term KaHA. Then we can rearrange it to actually get the value of Ka by moving the concentration of HA across to the bottom. So Ka in the end is the hydrogen ion concentration squared divided by the concentration of HA squared. In this case, Ka is one term and HA is also one term, so probably to simplify it, we can just use A, B and C letters so we get the same idea. So if A equals square root of B times C, find B, you have to square root both sides. So first of all, A becomes A squared, and the square root of BC becomes BC, as you've squared the square root. So in this case, you'd have A squared divided by C equals B. What you should do now is have a look at some of the chemistry calculations books, things like Jim Clark, and a variety of other exercises that you'll be given by your member of staff to practice doing rearrangements. We have maths booklets on Moodle as well for you to practice and test how your maths is coming along. If you're still having some trouble, there's always members of staff that can ask either in the maths department or the chemistry department to help you with some of your chemistry maths.